distance time graphs. This is an important topic also, especially in physics when you're studying about graphs. Let's make a graph. I can make one. Let me see here. I'll make a short one like here. Okay, so this is how it's like similar to making a bar graph, but the thing is that like you don't have to put bars. Let me show you. And remember, on this side, this is where the time, I think this is, yeah, yeah, this is where the time goes, and make sure it's either meter seconds or kilometer hour. So ms or kilometers hour. Like you can put the units here. Like suppose you want to say 0, 5, 10, 15, and so on, all the way 20, no, say all the way up to 50. Okay, and on this side you have to put distance. Let me write it like this. Distance. And the unit should be accordingly. It should be m/kilometers. It should either be in meters or kilometers. Okay. Okay, now let's put the units accordingly. 0, 0, 10, 20, 30, 40, 50. So do you guys notice something here? That they're cutting equal distance and equal time intervals. Like here it's 5, 5, 5, 5, 5, 5 up to 50, and 10, 10, 10, 10, 10. So when you graph it, it's gonna be a straight line, like this, and this is known as uniform motion. Uniform motion. Oh, this can also be for acceleration. However, let's not mention that. We'll do acceleration later. For now, let's focus on this. So this is the unit, and because there's equal distance and equal time interval, I'm sure you know this. I can't make it straight, but I'm gonna try. I'm gonna make it. Let me make. Oh no. Okay, wait. Well, yeah, this is a straight line. Okay. This is known as uniform motion. Okay. And remember, if you want to calculate the slope, okay, look, like for example, there's one more important thing here, that if you want to calculate the slope of this graph, and slope is basically the speed, so change, I'm just write d for short, change in distance upon change in time. This is a formula. It's basically speed, change in time. And now in here, like we can see, this is distance. It's 10, 10, right? So this will be 10 kilometer because there's an interval of 10. And here this will be, oh no, sorry, time is not in meter. Oh my god. Hold on a second. Hold on. Why Why didn't I notice this before? Okay, holy moly. Oh my god. Yeah, time isn't, oh my, just let me write. Okay, time isn't seconds or hour, okay? That was supposed to be the correct way. Yeah, seconds as hour, okay? So, and here, 5, 10, 15, 20. So let's suppose this is kilometer, okay? And then this will be 5 hours. So this is S, okay? Seconds or hour. Now what is the slope? The slope will be 2 kilometers per hour. This is called the slope. Okay? So the slope is change in distance, change in time. I'm sorry, please. It was second an hour, I'm so sorry. And like this can also be meter, second, there'll be 2 meters per second, okay? So I hope you understood this now. Okay? Now let's go somewhere else here. Let's see. So now we did, oh yeah. And basically this is uniform. And non-uniform would be like this. Okay. And so let's put the heading. Okay, distance count. Like every 5 seconds. Okay, no. Like for example, sometimes maybe it would have to go, suppose it's going straight, but what if due to traffic, what if it's going straight, but what if due to traffic it has to go curved? Then the distance would not be uniform, right? It will be different. However, the time is the same. Nothing happens to the time. The time usually remains. Yeah, because nothing happened to the time usually. Because it can be the same, but the distance, it'll kind of, because maybe due to traffic stops, red light, so yeah. And it could also affect the time. Like, there is a red light, the time intervals could change. So there's a possibility for this, keep that in mind. So you all understand like what uniform and non-uniform motion basically is. So I think that's clear. Just want to get an overview. Okay. So now let's talk about acceleration. Remember in uniform motion, the distance and the time could have the same intervals. Like the time could be 5, 10, 15, 20, 20, and the distance could be 5, 10, 15. It'll be uniform, okay? Now, distance. Okay, wait. Distance, time, graph, acceleration. Okay, let's make it. Okay. Oops, curved. Okay. Okay. So let me. Okay. So you can see here that now we know her acceleration is different. So you guys know that speed is distance over time, right? So in the same way, we have a formula for the acceleration. I'll write sort acceleration is equal to change in velocity. I'll just write velocity. See, velocity now velocity is similar, but it also involves direction. Velocity upon time. Okay, so here the time will be same. Like here we can put time, and on this side we'll put velocity. But there's no much velocity is like speed, but the units will be different. Last time we put distance, and the unit was meter per hour. But this time, this will be meters per second because velocity kilometers per hour. This is the unit of velocity, and acceleration is in meter per second square or kilometer hour squared. And time is as it is, because acceleration is like more than speed. This is velocity. So velocity has the speed, it also involves the direction. Okay? So there will be some changes in here. I mean, the graph will be same, but so just the units and the time. Okay, like let's say in here you put it, the time will be in seconds or hours. Okay, now let's put it 0, 5, 10, 15, 20, 25. Now if you want to make a uniform, we should also make this like in velocity 0, 0, 15, 30, 45, 60. So you can see that the going uniform, you can see the concept here. The time interval is the same here. Okay, but the concept is different. Acceleration is like more than speed. It's kind of faster, you can say. Acceleration. Yeah, because this is the formula, and since it's velocity over time, velocity is already like speed. Yeah, so because a meter per second or kilometer per hour, right? So yeah, and basically, and this is the unit squared. You can see square, right? Because we know that meter squared, yeah, remember that, okay? Or kilometer per hour square is greater than that. So yeah, the concept here is that the acceleration is like, suppose you have like an object is going uniform in the time interval, like for each 5 seconds, 20, there's a time interval specifically, and the velocity is going as the speed is going as per that, so it'll go a little faster because velocity involves speed and direction, but distance is only how far traveled. So do you understand that? Okay. And similarly, it's the same thing for non-uniform. Okay. This is uniform. I'm just going to put in text. Uniform acceleration. Okay. And it's the same thing with non-uniform. If you wanna, this is and if you wanna make it non-uniform, just make it curved. Oh, not like that. Say like this. Non-uniform. So the idea is the same between motion and acceleration. Non-uniform motion, uniform motion, non-uniform acceleration, and uniform acceleration. You have to mainly understand the difference between them, because there is a difference, and you should know that. So that's it's basically the same concept. But anyways, I hope you. And oh yeah, wait. Let's see the slope. Look, slope. So we already know slope, change in distance over change in time. But here it'll be change. Let's go put in text. It'll be change in velocity upon change in time, because velocity is greater than time. So if you plug in this, we get, let's see the time interval, 15, right? 0.53. So it'll be 15 meters second, let's say, and the time is how much? Let's say, yeah, 5 seconds. So this will be, and the slope, but in here this will be acceleration. So it'll be 3 meters per second squared. Okay, remember that. Because this is referring to acceleration. Okay? And the slope would be in the unit of the acceleration. Okay? So I hope I understood. If you have any problem, let me know in the comments. I think that'll be all for today's video. And yeah, see you later though. I'll see you later though. And yeah, we can use slope for uniform and non-uniform. We just have to do the change in the distance and time. So I hope you understood. Bye. Peace.